Okay, let's talk about how to solve this question. So we have y double prime. Let's take the Laplace of that. So you would have to use your formula sheet or a formula table to figure out the Laplace of y prime. And when you do that, you would see that Laplace of y double prime will be something like s square big Y of s, and then it's just gonna keep on subtracting from there. So minus s, right? The powers of s are also reducing, right, from 2 to 1 to basically 0, right? So s squared times big Y of s minus s, now little y of 0, right, minus y prime of 0. Okay, let me write this nicely. All right, so check out what just happened. We went from s square big Y of s to s y of 0, and then y prime of 0, right? So yeah, that's pretty much it. Now, if you look at the question, it says that y of 0 is 0, right? If you look over here. And y prime of 0 is also 0, so we got lucky for those two. So we could just literally cancel it out, right? Because that becomes 0, and this whole thing also becomes 0. Therefore, Laplace of y double prime just becomes s squared big Y of s, okay? Let's take the Laplace of positive 3ty prime, Laplace of positive 3ty prime, okay? So this, what you could do is you could just, pull out the 3t. You would get something like 3t Laplace of y prime, okay? So let's just do the y prime first, and then we'll add on the part of the t, okay? So that just becomes what? Actually, let's put everything together, yeah. So if you read the book, you have to recall that this t just becomes something like negative d over ds, right? Well, it's actually something like this, negative 1 to the power of n, and then d over ds, where this n refers to the power of t. So as you can see, the power of t here is just 1, right? Like t to the power of 1, which is usually invisible, right? So we know that then this will just be something like negative 1 to the power of 1, which is just negative, right? And that's where if you multiply negative 1 with dds, that would become negative dds, right? Okay, so just something that you have to be careful of. All right, okay, so let's work it out. So it'll be something like 3 times negative dds times, now let's write down the Laplace of y prime, which would just be 1s big Y of s, and then we'll just again keep on subtracting from there. So minus the powers of s would also reduce, so now you just have something like y of 0, right? You wouldn't have y prime because again, if you notice here, when we had y double prime, we only went up to y prime. So because we have y prime, we're only gonna go up to y. We're not gonna put y prime, okay? So that's what we will get from here. And as you can tell again, y of 0 is 0 based on this, right? So then we would just basically cross it out because that would just become 0. Now, what you have to do is you have to take the derivative, because this means to take the derivative, right? So you would have to take the derivative of this portion. Now, clearly, we would have to use product rule here. Need to use product rule. Must use product rule. Okay. Because we have s times y of s, right? All right, so also just a side note that big Y of s note is just the Laplace of little y of t. Okay, that's just what the big Y of s represents. All right, so be careful with that part. Now let's use product rule. So when you use product rule, you have to let your f be your s, right? And then your f prime will just be 1. Your g is going to be big Y of s, and your g prime will just be big Y prime of s, all right? Now, product rule is what is f times g prime. That is just f prime times g. So 1 times big Y of s plus it's big Y prime of s times forgot the parentheses there, times s, right? So that's your product rule. If you simplify this, you get something like big Y of s plus big Y prime of s times s, right? So that is your product rule. Now you also have to recall that you have to, once you take the derivative, you have to multiply with minus 3, right? Multiply with minus 3 because that's what we have there. So then just multiply this entire thing with minus 3. So we have that Laplace of 3ty prime is just negative 3 big Y of s plus minus 3s big Y prime of s. Okay, so that's what we have for this. Let's maybe put a little highlighter over there just to make our lives easier. Okay, so now we're not done yet. We have to figure out negative 6y, the Laplace of that. So Laplace of negative 6y, this is just going to be 6 times big Y of s. That is all right? And, I forgot to put the minus sign. I apologize. So negative 6y. Yeah, okay. So, yeah. And then the last step we have is Laplace of 2, right? Because we have 2 here. Okay, so that is the same thing as saying 2 times Laplace of 1, right? I guess that's a little bit easier to figure out. Now, again, you would have to use a table right, to figure out that Laplace of 1 is actually 1 over s. So we have 2 times 1 divided by s, right? That just gives you 2 over s, okay? All right, so that's pretty much what we have to do. All right, so let's look into the next step. Oh, I forgot to highlight this one too. All right, so now putting everything together, we have considered the sign and, everything else. So now let's put everything together. So together we have, first we have s squared ys, right? S squared big ys. The reason why I'm writing down s a little bit differently is because it kind of helps me differentiate between s and a 5 because I have a hard time differentiating between them. Okay, so then we have, let's see, oh, here, then we have negative 3 big y of s minus 3 big y of s prime, and then we have negative 6 big y of s. Then we have, we're just gonna set that equal to 2 over big s, 2 over s, sorry. Let's make sure that we have everything covered up. S squared big ys minus 3y big ys minus 3s big y prime of s. Okay. Minus 6y big ys. All right, good. Now we're gonna put big y s together, terms with big y s together, then we're gonna factor big y s out of them. Okay, so I'm just gonna skip a little bit of step here. I know that this one has, let me just mark it with like a red color, it'll be easier. This one has big y of s, big y of s, and big y of s. We're just gonna like factor out the big y of s. We have s squared minus 3 minus 6, and then minus 3 s big y s prime equals 2 over s. Okay, so after this step, this just becomes what, s squared minus 9, right? So that becomes s squared minus 9, and let's see, do I want to factor it out, or how do I want to proceed from here? Let's see. Yeah, let's factor it out, because I know we have to use something called the integrating factor method here. So let's factor it out. That's gonna be, that's gonna be s plus 3, s minus 3, right? If you multiply them together, you would end up with this value, right? So that's that. So we have big y of s times s plus 3 minus, not minus, times s minus 3 minus 3 big of s, and then y prime, big y prime equals 2 divided by s. Okay, so now let's let's just put this into integrating factor form, right? I mean, you want in integrating factor, you want the prime to be left alone, right? Like you don't want this minus 3s over there. So actually, because I think, because I know, okay, so if we divide this with all of these, then it's just going to become a little bit more complicated. So let's just put it, let's just erase this part, actually. Yeah, let's put it into just this form. I think that'll be a better way and much more easy to integrate. All right, so then we have something like let's see, so let's put it into the form. So we have something like negative 3s big Y prime, okay, and we have plus big Y of s squared minus 9 equals 2 divided by s. So this is in that form right now, and you just need to like basically divide all the terms by negative 3s, right? If you divide just this portion by negative 3s, and you would have to also divide this by negative 3s. So that just gives you 1 here. So you have big Y prime of s is not equal to, plus big Y of s. And if you want, you could simplify this, right? It's up to you. So let's see, this, you will get something like s squared over negative 3s, right? Well, yeah, and then plus 9 over 3s equals 2 over s times this should be negative 3s squared, right? I mean, if you recall that this portion, like you could do something like 2 divided by s times, like this has a denominator of 1, so you could flip it upside down, so you get 1 over negative 3s, right? That just gives you, like, if you multiplied these two denominators, you would end up with this, right? Okay. All right. So if you want, you could put the negative on the top. That doesn't really matter. I guess it's a convention to put the negative on top. So yeah, that's fine. Okay, so then we would have something like big Y prime of s plus Y of s. And I mean, if you do this part, this part here, you would end up getting something like negative s on top and 3 in the bottom. And plus, if you do this part, 9 divided by 3 is just 3. So 3 on top and s on the bottom equals negative 2 divided by 3s squared. Okay. Now, some people prefer to do the integrating factor by mu, and some prefer to do it by rho or some other Greek letter. I'm going to do rho. So rho will be my integrating factor. So rho of s will just be e to the power of p of x. P of s, and P of s in this case will be something like this here, right? Like I'm going to take that and put it on top, right? And I'm going to integrate with respect to s. So negative s over 3 plus 3 divided by s ds. You should know by now that if you integrate negative s over 3, you would get negative s squared divided by 6. If you multiply 2 times 2, that will give you 6, right? Plus 1 over s is just ln of s, right? So it will be 3 times ln of s. We don't care about the absolute value here. So you could just put s there and plus c, obviously, but again, you don't really have to care about it right now because that'll be taken account for later on. So yeah, that'll be pretty much it for the constant part. I know it's a lot of work, but yeah, I think we should be okay. All right, so let's see. So rho of s is just going to be e to the power of negative s squared divided by 6 times let me double check this part. Yeah, times so you could rewrite this ln portion by doing something like ln of s to the power of 3, right? So we'll do that. I'm just gonna put it here, times e to the power of ln of s, I believe, yeah, to the power of 3. And recall that e and ln just cancels out. That will just give you s to the power of 3. So you're gonna end up getting something like s to the power of 3, right, times e to the power of negative s over 6 squared. Okay, so that will be your rho. That will be your integrating factor. You're going to take this, you're going to multiply the integrating factor with which term was that? With this whole equation, right? That is if you want to. It's up to you. But if you don't want to, that's fine. So but what you have to recall, though, it's something going to be like this: integrate of dds, right? And then you would have to put your integrating factor, or you could put your big Y of s, that's fine, times your integrating factor, which will be s to the power of 3 times e to the power of negative s squared over 6 is equal to the integrate of negative 2 3 s squared times s cubed e to the power of negative s squared divided by 6. Okay, like I said before, you would have to take your integrating factor and multiply it with this term, and this term, and that's why I'm putting the integrating factor here, right? Okay. If you think about it in a way, if you take the product of these two, you would end up getting this whole thing, right? Okay. Like if you do the product rule, right? But that's a little bit hard to figure out, so so always remember that it's going to be your integrating factor, times, your y of s or big X of s or whatever your professor gives you, right? Okay. And then turns out these just cancel. Integration and derivative just cancels out. So you are left out with something like big Y of s times s to the power of 3 e to the power of negative s squared divided by 6. And here you would have to do a u sub, okay? So if you do a u sub, so you're going to let your u be, let's see. Well, even before doing a u sub, we could simplify, right? So what do I mean by we could simplify? Let's see. We'll get something like negative 2 s to the power of 3 divided by 3s squared e to the power of negative s squared divided by 6. Now check this out. You would get something like this on the bottom for the right hand side. You would get negative 2 over 3 times just s to the just s, and then e to the power of negative s squared divided by 6, right? So that's much more simpler. So always try to simplify first before integrating, because then it just makes your life more easier. Forgot the integration part here. Okay. And yeah, let's integrate right now. So if you integrate, this is going to be side note, u is going to be, well, you have to be smart about it, right? You cannot let your u be here. You don't want to use integration by parts really quickly. You want to try to do it by using u sub first, right? So if you think about it, we have negative s squared divided by 6, right? And then d of u will just be negative 2s divided by 6, d of s, right? If you flip it upside down, you would get something like negative 6 over negative 2s ds, right? Sorry, I forgot the du equals ds, right? And yeah, that just gives you, that just gives you what? That just gives you negative 3s d of u equals d of s, right? You take that and then you plug it back in, right? Here, for the u part. So we have integration from negative 2 over 3s on the top times e to the power of u times negative 3s. I think I messed up somewhere. This should be negative 3 over s. Sorry. Negative 3 over s. Negative 3 over s because, again, s is on the bottom, right? Okay, so then this will, you can clearly see that the s's cancel out, right? Because s divided by s is just 1, and then, the 3's cancel out, negative times negative gives you positive. You end up with 2 e to the power of u, which is just, 2 e to the power of negative s squared divided by 6 plus c. This time we have to put in c because, and we have to put a constant for the entire thing. Just one constant for the entire, equation is enough. So we have big Y of s times s to the power of 3 e to the power of s squared divided by 6. And I'm just going to copy and paste it because I'm getting exhausted. So paste. And we're just going to set that equal to just like this part here, right? Oh, sorry. This part here that we just got. Okay. So it'll just be 2 e to the power of negative s squared divided by 6 plus c. Okay. And if you divide this on the both sides, you would get something like this. All right, you would get something like 2 over s cubed plus c over s cubed e to the power of negative s squared divided by 6. Okay. So you could leave your answer like this, right? But if you want to simplify more, what you have to remember is this rule that says that oh well, first of all, you have to rewrite this whole thing. Let me rewrite this whole thing. I'm just going to copy and paste it. You have to rewrite this whole thing as what? Because you have a negative here, the sign, you have to put that on the top, right? Not the negative sign, sorry. But yeah, so there's a rule that says c of when you take the limit as s is approaching infinity of the Laplace of f of t, that just becomes 0 apparently. I think the rule is something like, because exponential is growing faster than the bottom, that's why your c turns into 0. It's something like that. So yeah, you could use that rule to say that, oh, because of this rule, c is equal to 0, so we know that big Y of s is just equal to 2 over s to the power of 3, because you can see is equal to 0. And for this one, you would have to use another formula sheet, which says something like, let's see, which said something like, recall that Laplace of, I believe, t of n, t to the power of n, is just n factorial divided by s to the power of n plus 1, right? So if you think about it, what plus what gives you 3? N must be 2, right? So because we have 2 factorial divided by 2 plus 1, that makes sense. So we know for sure that our t will be 2, right? So you could just say that little y of t is just going to be t squared. So this will be your simplified answer if you want to. If you don't care, that's fine. I would just leave it up to here. Where did I just left up to? Yeah, I would just leave it up to here. I think you should still get full credit for that, because not a lot of people know about this rule, or something that's similar to that. Okay, so with that said, thank you for watching, and I hope this helps you, and I'll see you soon.